kind of talking from here is personal experience. As auditors, as inspectors, I spent 18 years, 10 months with the Minnesota Department of Ag. I left there 20 years ago to go to work for Wayness and Associates. And that's a kind of an intense program because we do a lot of work overseas and in foreign lands. Our work is very much centered around the Grade A Pasteurized Milk Ordinance. You can see the current revision, 2019. This slide Dr. Warren had earlier, PMO Section 7, Item 11P, page 73 of the 2019 revision of the PMO gives us that reference to the 3A sanitary standards. My business partner, Ken Anderson, was instrumental in getting that note revised for the 2017 revision. PMO, of course, is everything from the cow to the carton. My own personal experience in the dairy industry started with this milker bucket. When I was 12 years old, my job was to clean that guy after every milking. And if you notice on the Surge milker bucket, there are 4 slip joints where the inflation or the milking cup meets the milker. You had to pull those apart every day, and they had to be cleaned, thoroughly cleaned. If you didn't clean those perfectly, you would have undergrade milk. The other thing is, I wasn't big enough at the time to pick that thing up because it had about 4 gallons of milk in it, and I wasn't, strong enough to get that out from under the cow. So they made me wash the damn thing. Then we moved on in the dairy industry to pipeline milkers. Of course, we have the 4 slip joints, putting those inflations to the milker claw, and now we've added 2 more slip joints for this milk tube that carries milk from the cow to a pipeline. The pipeline milker goes off to the milk house. Now, were those slip joints thoroughly cleaned after each milking? Were they taken apart? No, but we've come to accept these slip joints. Okay, we accept it as dairy inspectors and food safety professionals. Time moves on. Now we have these big milking parlors. This happens to be a rotary milking parlor used for milking goats. Now we've gone from 6 slip joints to hundreds of them. Do they get pulled apart? No, they don't. But we rely on a CIP system to clean that equipment. Now, I don't know if you recognize the gentleman standing there. That's our old friend, Dr. Ron Schmidt. Slip joints. Not a big fan of slip joints because of my experience in my younger days and having to clean those. Now, you'll see the hose connection there. That was part of a milk transfer system for this farm. They use that to pump milk from the milk house to the delivery truck. And of course, it's a slip joint with hose clamps. Do they take that apart every day and clean it by hand? No. I happened to write this particular farm up for slip joints, and they needed to go with an interlocking or a hose assembly that would meet 3A for that farm. Now, I've gotten some pushback on that from the farmer. He's saying, no, I'm not spending that kind of money. And I said, well, then you don't need to be grade A now, do you? He changed his mind. More slip joints. I spend a lot of time with milk tank trucks doing inspections and making sure that everything, that these slip joints are pulled apart. Do milk truck drivers and do dairy plant operators pull the slip joints apart on the transfer hose, on the unloading hose? Hopefully the unloading hose meets the 3A sanitary standard for hose assemblies. Just as a kind of reminder, so sometimes I kind of think to myself, yeah, what's the difference between a milk tanker and that guy right there? They use slip joints too. Okay. Of course, we spend a lot of time doing tank truck inspections. I'm kind of the culprit behind Appendix B, Part 8, the National Milk Tanker Inspection Program found in the PMO. I wrote the first version of that after we had this salmonella outbreak from Schwann's ice cream here in Minnesota. We found out at that time that we didn't have the authority to license and inspect tank trucks in 1995. I sat down one afternoon and wrote that, took it to the NCIMS Hauling and Sampling Committee, and now it's part of the PMO. Tankers have to be licensed and inspected. There is a movement in the milk transport industry to try to get people off the top of milk tank trucks. There are numerous accidents every year when guys fall off the top of these. It's happened to me. I've fallen off the top of one of these. It's not fun. I'm also responsible for another clause in the PMO that has to do with Appendix N testing, animal drug residue testing of every tanker every day. I submitted a proposal to the NCIMS to add the wording at the bottom of Section 7, Item 15P, A, 3B, when weather and environmental conditions permit, manhole openings and covers of milk tank trucks may be opened outdoors for the short period of time necessary for the collection of milk samples for animal drug residue. I have had my butt kicked for this for 10 years. People are still kind of angry about that clause, but there it is. We're going to jump from raw milk to pasteurization. Of course, we use 3A to evaluate all this equipment. Pasteurization, aseptic processing, packaging, that's all part of PMO, but now we do have this reconciliation between the PMO and aseptic processing. Of course, FSMA is now part of the PMO, or PMO has been brought up to FSMA standards. Appendix T, which gives us instructions on how to comply with FSMA. The 3A sanitary standards, my note at the bottom there, are a building block for verifying this requirement. We have a flow meter which meets standard 2804, and that's kind of how we want to see it labeled. Of course, 3A standard covers all these things. Previous speakers have talked about this particular slide before. The EDTCF is important to us as CCEs. We really pound away at those documents when we're doing our audits. Does an equipment manufacturer have a quality management program? Are they certified under another third-party audit system like ISO 9001 2015? I believe there's a 2018 revision to that now. Rubber and rubber-like materials are a big focus for us as CCEs. We want to make sure that these materials are compatible with the environment of intended use. We still use standard 18 and 20 when we do our audits to see that the materials are compatible. Non-metals is part of the general requirements. When we look at declarations from rubber and plastic manufacturers, we're always read those statements very, very carefully. You sometimes see these statements at the end of the document. It'll say, it's the responsibility of the article producer or food packer to determine that the article is suitable for its intended use. Even if they're claiming compliance with Title 21 of the CFR Indirect Food Additives Law. And they'll make statements like, when used unmodified. Well, a lot of manufacturers will, a lot of guys that buy rubber and plastics will sometimes modify that, or they'll make an addition to that material. So we're always kind of watching for these statements to make sure that what they're saying is true. Other considerations that would comply with ConAg, not all states adopt ConAg as their rule because they mine for things like cadmium, lead, mercury, and hexavalent chromium. And then, of course, food allergens. We've talked a lot about cleaning, CIP versus COP. This is a little slide presentation that I did for a training course for a dairy. We had 4 pieces of equipment that were considered COP only. You see these nice, clean, shiny fittings and valves in the picture. Those had been COP cleaned, but they didn't pull them apart when they put them in the COP tank. So were they clean? No. When we pulled them apart, we found all kinds of fun things floating around in these parts. Of course, we like to see things that are labeled 3A. Now, does this particular valve meet the 3A sanitary standard for drainability? Depends on how you mount the damn thing, right? The standard for sensors and sensor fittings are one of the biggest group of symbol holders in 3A. Here's a particular fitting that I was looking at in a dairy plant. It had a 3A symbol on it. Did it meet the standard? Yes, it did. But when we pulled it off of the equipment, this particular sensor had an adapter, and the adapter was not mounted correctly. So now we had this problem. Now you're out of compliance. But it was easily fixed. It just had to be assembled correctly. So you have to look for that kind of thing too when you're in a dairy plant doing inspection. Constructed to withstand the environment of intended use. Okay, why do we need the plastic bag? This is a pretty aggressive area. This is above a balance tank on an HTSD pasteurizer, and they spend hours cleaning that equipment. And there's a lot of steam, there's a lot of hot water, and they had to put a plastic bag over to protect this particular sensor. We spend a lot of time looking at processor vats. This particular one, you see on the left-hand side of the picture, that was the original vent. Did that protect us from any uncontrolled water? That's the first time I heard uncontrolled water today from Dr. Warren. So I drew up this little picture and I said, okay, we gotta protect this. Here was the manufacturer's answer to that. Oh, we'll just put a little steel around the sides of it and that'll take care of it. Okay, so we're only gonna spray water at that from one direction. And then we look down the barrel of that thing and you can see these spot welds. They are bad news. But how do you get in there to polish and clean that or weld that properly? I don't know. One of my concerns with batch pasteurizers is the proliferation of cone bottom processors in batch pasteurization. If you read the PMO correctly, you have to have this sweeping action across the face of the outlet valve to make sure that no product sits there for any period of time while you're pasteurizing. You got to keep everything moving, you got to keep it hot, up to temperature, all of those things. With a cone bottom processor and this particular agitator configuration, I don't know that that meets the PMO. So that's something that needs to be looked at very carefully in the future. All non-product contact surfaces coatings shall adhere. Did that coating withstand the environment of intended use? Here's a picture of a progressive cavity positive displacement pump. The pump shell has a coating on it. I would say this coating didn't survive the environment of intended use. Filling and packaging, of course, very complex equipment, and it takes a long time for a CCE to go through a machine to make sure that every part of that meets a standard. Sometimes these filler valves get pretty complex, a lot of O-rings, a lot of seats that have to be looked at. We still have a clause in the PMO that says you can use woven wire screens on fill valves to knock down foam. However, with the caveat, if you use those, you have to autoclave them after each use or before you use them again. Sanitary welds are looked at, and I know we've talked about this in the last day, so I'm not going to spend a lot of time on that. Display of the symbol. For a CCE, that's probably one of the most important things to get right. As you can see, we've got two caps there that I found in a dairy plant. They both have a 3A symbol on them. Which one is correct? Where you place the 3A symbol is important. The picture on the right is a filter assembly. They happen to put this 3A symbol on a spool piece between these two filters. Okay, which part of that is 3A? The filter housing, that's it. So here we got the 3A symbol in the middle. It doesn't really tell us that the filter housing is okay. This is probably one of the more correct ones. I'm not too sure about the rivets there, but there is an allowance for that. This is one of the oldest 3A symbols that I've encountered. The Sunset Equipment Company built milk tanks here in St. Paul, Minnesota years and years ago, and they were a 3A symbol holder, and I emptied tons of those tanks when I was a milk truck driver back in the 1980s. This is one of our business colleagues. We were down in Columbia, and they told me if they got a bad score on their milk plant, that rope was going to be useful for ending things. Thank you for your attention.
I kind of approached the subject a little bit differently. If you've been in the industry for very long and you have anything to do with ice cream plants, they now have a target on them, and they rightfully so, actually, because they have been not very well scrutinized in the past. Ice cream was always treated such as that it was frozen. Nothing would grow in it when it's frozen, okay? But we've had some pretty jarring experiences lately where ice cream has caused some big, big problems. Environmental programs, that's what we're looking at. We're looking at the way to be able to find out why that pathogen or that bug is getting into our ice cream. Used to be voluntary almost. You go out, you swab a couple of drains, you wouldn't find anything. That was the end of the story. Today, not so. It's a paradigm shift for a lot of the companies that make ice cream, because they're not used to having to be that thorough and accurate about stuff. Why now? We've had several major sized plants in the United States that have caused illness and death in ice cream. Some of them have fallen through the cracks. One of them, even they had a plant that wasn't even on the food registry. That's going to affect the whole industry. There were several flavors at this one in southern US. There were several flavors and lots that were recalled due to a problem. The fast facts were there were 28 illnesses, 27 hospitalizations, 1 death. There were 11 states involved. It was recalled, and the investigation at this time is considered closed. But they did have some major problems with that one. There were several that come in a row. Between 2000 and 2020, there were 88 ice cream associated outbreaks that were reported through CDC's website. The main bugs that they found were Salmonella, Listeria, E. coli 0157H7, and Campylobacter jejuni. They had not really, some of those bacteria hadn't even been considered in ice cream at one point. Now we're starting to see where we're getting more and more reports of stuff like that. So in the Journal of Food Protection, which is, we all probably read, Hygienic Shortcomings of Frozen Dessert Freezing Equipment, Fate of Listeria monocytogenes on ice cream soiled stainless steel. That's a big saying right there. The magazine goes on to talk about the abstract on this study. Although frozen desserts have strong record of safety, recent outbreaks have linked ice creams to certain foodborne illnesses, and that has brought more attention to the ice cream industry. There is a concern that small-scale frozen dessert equipment may not comply with or be reviewed against published comprehensive design and construction sanitation specifications. And in particular, they mentioned the 3A sanitary standards. It goes on to say equipment sanitary design issues may result in the reduced efficacy of cleaning and sanitization. We've talked about that for 2 days. You know, equipment design. And also they talked about post-process contamination, which is where we're going to find a lot of that stuff. Typically, your pasteurization systems, if you're in a state or in an area where they're getting inspected, you're not going to find a problem with what's coming from them. You're going to find a problem with post-pasteurization contamination. And that's a lot of times it's an equipment issue, because maybe the equipment doesn't have covers on it. It may be a piece of equipment where you can't pull it apart completely and clean it if there's crevices and cracks. It's just in the ice cream industry, they haven't been really looked at that closely. So it's going to become more and more of a target, or more and more of a thing for the industry to watch out for. And we should have been doing it anyway. Results that showed Listeria monocytogenes survived up to 6 weeks at room temperature and 9 weeks in 4 degrees Celsius in contaminated ice cream on a stainless steel surface. And so the documentation of those recent outbreaks has validated that fact, because we know now it's getting in there. It's surviving. It's actually growing to a certain degree in parts of our plants, and we may not be following through. So, new requirements. New requirements in ice cream plants, swabathons. And it is a major thing. Hundreds of swabs taken, very meticulously done, pointedly at pieces of equipment that may have areas where it may collect part of the dirt on the floor, or it may go through a traffic area, or it may just be sitting with a hollow leg, anything like that. It's going to be looked at very closely. And so we got this listed now in Title 21, CFR Title 21, Part 117, and we are now subjected as an industry to these requirements. The program is seek and destroy, not hide and seek. I can't say that enough. It's our job to find this stuff. We are selling a product to the consumer. I'm talking as a company. We sell product to a consumer group, and especially children, and we better know what we're putting out the door. And if we're going to shy away from things like we found something in a drain and we don't want to follow along and we just kind of ignore it, that's not going to work, because it'll catch up with you somewhere along the line. Zones are established when you find an organism. You establish the zones, you take the actions immediately to make sure that you follow up on that presumptive positive hit, and nothing is cleared, everything is suspect until you clear that whole thing out. So zones are defined pretty much: food contact surface, near a food contact surface, hygienic areas that are non-food contact, but they're close to the equipment, and then non-hygienic areas like warehouses, hallways, and refuse areas. Dan had the great welding chart we all have used for a long time as a good training tool. That really does apply, and especially in ice cream equipment, because sometimes they aren't as highly regulated and people don't check to see how that welder does his job. Ideally, a regulatory agency would ask for sample coupons from each of the welders that are going to do that sanitary welding and judge how that looked as is, not after polished or anything else. And they get a good idea of how well that welder may be able to do it, and he'll be okay for doing the plant then, or she. It's obvious that they fixed this on the fly. They probably had a split or something in that pipe and they had to seal it, and they just welded it as is. So you can see that the gasket's welded into place, and it's a real messy situation there. Other areas of concern: corrosion from the poor choice of metals. We have metals in some of the ice cream equipment that is not set up to be used, and we talked a lot about this, conditions of use. And so we get some of the metal that galls, and we have metal that corrodes under regular conditions. That's a problem. Then you also get into the corrosion and pitting on the plates and the heat exchangers. That can come from many different things. It could be just from general wear. It might be because there was a stress, fracture, or flaw in that piece, but no matter what happens, when you have a pit, you're going to have an issue with bacteria that can grow there. Because if you build it, they will come. We also have different pieces of equipment where we're outside of the product surface area, but we still have concern. Sandwich joints, places with threading, any place where you might have a handle or something where it's fitted against the machine. All of those areas are what are concerning, and that's some of the stuff that a good person in a plant can step back and look at it and go, I think we better check that place. I think we better check that place. And definitely got to check that place. So corrosion and pitting on the plate heat exchangers, though. The example on this one, it appears that they were using an incorrect chemical or left some type of a chemical in there. It really did do the job on it. We don't open those plate heat exchangers every day. We wouldn't know that was in there. It'd be a great program to have in place to check those ever so often. The area in between the footer under a tank, there's a lip there. It's real possible that the seepage gets under that. It'd be great if those were sealed. Now, I'm not going to find that everywhere you go, but it's a lot better sealed than it is left open like that, where water can get in and out and bacteria can grow in there. Belts, you know, they'll tell you they can clean a belt in the COP tank, and the belt's about 40 feet long. You can't get that in the COP tank. Different areas along the belts, the rails. Some of the rails are even actually close enough to be considered product contact if you're using it, that conveyor for novelties. Here's an example of some of the different designs that are poor and how they can be corrected. It's a hand drawing. I know it's not real official looking, but at least it gives you an idea that we want to leave it either open or completely closed. You can't have any types of flat areas where something can perch and get underneath and grow. And again, if you build it, they will come. We shouldn't be providing a place for these guys to have their parties. We got to make sure that our equipment's in good shape. And the only way to do that sometimes is to get in there and pull it apart. It's not always fun, but it is a good way to know how good a job your equipment's doing and getting cleaned. So, abbreviated conclusion. Poor plant and environmental conditions encourage bacteria to populate. That's just common sense. It's not a surprise that if it's in the environment, the bacteria will find a way to get to the food. That's their job. That's what they want to do. Exposed, poorly constructed equipment, poorly maintained equipment will provide a niche for bacteria to grow. We got to kind of keep an eye on that. And that's another thing about making sure our sanitation maintenance programs are in place, where we replace those gaskets and we replace those clamps when they're stretched out, and do all the right stuff at the right time and judge it by how it looks when you pull it out of there, especially gaskets. Prevention is the best solution. And we have to have equipment that's provided that's easy to clean, easy to pull apart, and nobody goes to work and wants to have to work 3 times as hard to pull a valve out of the system to change the valve plug. Make it so that they can get to it, the workers can get to it and get it done easily. And it'll be done more often that way and done in a better way. So that's the end of my little spiel. Thank you.
Good morning, everyone. I am Dennis Glick with USDA. I am official title would be Plant Survey and Equipment Review Coordinator. I've been with the department 37 years, 9 of that as a butter grader, cheese grader, and plant inspector. The remainder as an equipment review specialist. What I'm going to do today is discuss the differences between USDA dairy requirements as far as equipment as opposed to meat and poultry. So what I'm going to do is take a overall view of the differences between the equipment requirements for the dairy industry and meat and poultry from a USDA perspective. With USDA dairy, first and foremost, we are required to use the 3A sanitary standards where they apply, and this is written actually in the Federal Register. So there are certain times that there are pieces of equipment that do not have a 3A symbol. In cases like that, we use the USDA guidelines. That's a generic document that is written to cover all of those pieces that are not covered by a 3A sanitary standard. So it's really similar to the general requirements of the 3A. With meat and poultry, there is a USDA guideline that covers all of the meat and poultry equipment. Now, in this guideline, it describes 3 separate NSF documents that are to be followed when reviewing meat and poultry equipment. So the first of them, which is 14-159-1, is a generic document. It covers all equipment. 159-2 is specific to handheld equipment. So if you can hold it in your hand, it could be a knife or a scraper or something larger, some type of saw. As long as it's manipulated by hand, that's covered by this standard. And then last but not least, 159-3 is for belt conveyors. Now, as I stand here today, there are probably more USDA certificates of acceptance written for number 3 than any other one, simply because of the amount of conveyors that are used in the meat and poultry industry. I would write several certificates out, per month, I would think, at least renewals for people that are having their acceptance has expired or is about to expire and they wish to renew. Now, one of the major differences between meat and poultry and dairy is meat and poultry uses risk assessment. I'm not going to read all of these to you, but I will read number 1 and number 5 as well. In number 1 is equipment which, following a hygiene risk assessment, needs only to partially conform to the requirements of this standard to meet identified risk and to produce a safe product. Okay, so what does that mean? You could have the same piece of equipment on the kill floor and it would pass the inspection. The same piece on the ready-to-eat end of things would not pass, simply because of its construction. As you read the last one, this would be more on the ready-to-eat, the most sanitary requirement for its construction. Equipment which, following a hygiene risk assessment, will prevent microbial ingress and has been designed for specific heat, chemical, or physical treatment to free the equipment from relevant microorganisms. One of the other major differences between dairy and meat and poultry is this symbol that you see right here. Meat and poultry, they have the right to put this on their machine or piece of equipment if it complies. Dairy does not have this opportunity. It literally will take an act of Congress, without a joke. It has to be read into the Federal Register for us to use this with the dairy industry. This is similar to a grade label shield on butter. Most of you have seen that mark right there. That is the department that we work for, the dairy grading branch. To put this on your machine is the same process that you have to go through to be able to use that on your butter. Basically, it gives the consumer, or I shouldn't say consumer, the purchaser of the equipment assurance that this has been looked at and it complies with all of the guidelines that it needs to be used in their plant without question. Let's talk about the product contact surfaces. I think, everybody that's had anything to do with 3A could repeat this in their sleep. I know. All surfaces which material or liquid may drop, drain, or be drawn into a product contact surface or packaging material, etc. It's the same for meat and poultry. The interesting thing about meat and poultry is you have different zones, and the criteria changes from these zones as to what's allowed and what's considered the product contact area. For example, in zone 1, these basically are direct in contact with the product. In a zone 2, these are surfaces which are incidental or indirect contact. They may have roughened surfaces by knurling, grooves, ribs. These things are so that on a hand manipulated tool, you will be able to grip it or to hold on to it, or it's a knob or it's something else like that it has this ability to be manipulated easier. Knurled surfaces, not allowed. And in most 3A standards, it's not allowed on a non-product contact surface. So that's a major difference between the two departments as far as that goes. Now, one of the things we talked about before was belt conveyors. Like I said before, and without reservation, there are more USDA certificate holders of belting and things related to belt conveyors than anything else, simply because of how many are being used. So let's talk about those just a little bit. Within dairy, product contact surfaces of anything plastic has to be a 63 microinch or better. Meat and poultry, plastic belting is exempt. That's a major difference between the two departments, or the criteria for each of between dairy and meat and poultry. Dairy, we require the 63 micro-inch, but we don't require any additional testing. Now, we do review these, and I do several tests on them, but there isn't a specific, I will say this in quotations, laboratory test that has to be done to prove cleanability. However, meat and poultry, there is a specific test called out in 159-3, section 6, where they literally soil the belt and they use riboflavin. And they've built an apparatus that they flush the belt and they try to clean it, and then they review it with black light to see if there are any harborages in there. And I guess that's how they can get by with the rougher surface finish, because it's possible that to move meat on a conveyor that they need the roughened surface. And they can prove cleanability by using this test that's described in 159-3. For dairy, it must comply with the USDA guidelines. So because we don't do the test, we hold them to the criteria of everything else within the guideline. We check for absorption. Does it wick? Is the backing impervious to water? Is it cleanable? Now, as far as materials, meat and poultry, they say 300 series, and they don't make any other distinction. As opposed to dairy, which in most cases we don't allow 301 or 302, in some cases 303. But 302 is allowed in certain applications because of the springs. It's spring steel. It's necessary. Meat and poultry, carbon steel is allowed for cutting surfaces, knives, things like that. Not allowed in dairy, just due to its corrosion characteristics. Within meat and poultry, no glass. They don't want glass anywhere. Within dairy, glass is allowed in certain applications, light and sight ports, things like that, where you need to do inspections for whatever reason. It does have to be special glass. You just don't go to Walmart and buy it. It's heat resistant, shatterproof, etc. Meat and poultry, no uncoated aluminum and no uncoated anodized aluminum. There are specific grades within dairy, within the 3A, that are allowed to have aluminum uncoated in its natural state. But it's only a few grades, and then only in dry applications where there's no liquid. So aluminum could be used provided that it was coated with proper material, plastics sometimes, rubbers, also electroless nickel or chromium is a possibility, because in that particular case, the substrate isn't the concern, it's the surface on the outside. RTV silicone that meets FDA can be used in product contact areas in a meat and poultry situation. That is not allowed in dairy. The only exception being in 3A standard 26, where it is a sifter standard, it's allowed as a buffer between the screen and the frame because of the vibration that takes place. It helps to buffer that vibration to prevent any tearing of the screen. Plastics, rubbers, and nonmetals. Within dairy, we allow usage of plastics and nonmetals between 21 CFR 170 through 199. It's a pretty broad range. Within meat and poultry, they've shortened it up, 174 through 189. We also allow the use of material if it meets the GRAS requirements, and that's also okay in meat and poultry to be used. A prior sanction letter, this is similar to 3A. Actually, I think we've used it exactly as 3A to draw the two together. Within meat and poultry, the material can be exempt under 21 CFR 170.39. The valid threshold of regulation, the TOR for dairy. Within meat and poultry, the pre-market notification. And obviously, I won't take the time to read those. But anyway, there are 6 methods there And one additional one, if it complies with 3A Sanitary Standard 20 or 18, it would also be acceptable. So there would be 7 ways to certify your plastic or rubber or non-metal. Briefly, let's talk about radius. And a radius is required for interior angles less than 135 degrees in a product contact area. So with dairy, we start out at 1/4 inch. That's basically where it starts, unless a specific standard makes an allowance for it. But the 1/4 inch would be where you would start, as it's a relatively large radius, very cleanable. If it's formed or machined, so if you have a radius or internal angle that has been formed on a lathe or a milling machine, it would be 1/4 inch. Within meat and poultry, they start out at 1/8 inch. They say that's big enough as long as it's cleanable. Now, dairy says 1/8 is okay too if you created it by welding and the thinner of the two materials is 3/16 or less. That has to do with warpage and other things. Now, we're saying that the 1/8 inch radius will clean as they do in meat and poultry, but it's how it is created is why the 1/8 is allowed as opposed to the 1/4 inch where they start out with the requirement. Smaller radii are used for functional reasons. There are certain things that are put together like seals and other components that require tight fits. You can't have a 1/4 inch radius because they won't fit together. So in those particular areas, dairy does make an allowance to go down to 1/32 if there is a functional reason. It's the same for meat and poultry. We do allow press fits where welding is impractical. In such cases, you do not have to have a radius. It can be a 0 radius. It's just impractical to try to form a radius on a press fit or a shrink fit. And it's the same for meat and poultry. They allow it as well. The one exception is to the 1/8 inch rule with meat and poultry is if you have a 3-plane intersection. So basically a 3-plane intersection would be a corner of a vessel where the two sidewalls come together and meet the floor. That corner would require a 1/4 inch radius. That's the only time that they actually spell it out, that it has to be a 1/4 inch. Lubricated bearings. Within dairy, we say you have to have at least 1 inch open clearance. Now, open clearance means you have to see it. And the purpose for that is so that the operator can look and say, wow, that bearing is failing, or ooh, it's over greased. If that area is enclosed, you have no idea until the grease is already in your product. Meat and poultry, they say, just give us a cleanable distance that's adequate. So there is no dimension called out. That swings the door pretty wide for them. However, it's in the eye of the inspector to say that's not enough. Or I can't see, or the operator can't see what's going on inside there to make a determination if it's too close or if the design is okay. One exception that dairy has made to the 1 inch rule is for permanently sealed bearings. So that's a factory sealed bearing that is non-greasable. Now, the reason we've done this several years ago is there is a specific amount of grease inside of that bearing. Normally just a few milliliters at most. And so in certain cases, and then only on conveyors, we have made that exception that they could have a 1/2 inch. We thought that that would give us enough room to make an assumption or a judgment if that bearing has failed. Now, hopefully, if that bearing would fail, the operator would know that bearing has failed based on its noise or just their initial inspection of it before startup, that there's a problem that would need to be re-repaired. Now, if it's a greased bearing, they over-grease it, the grease just comes out into the product. I've seen it before. With this particular case, the bearing would only have, like I say, a prescribed, only a few milliliters, so not that much. Easy to judge if it has failed. Spray devices. Within dairy, they have to comply with 3A Standard 78 if they're left in place during production. If they're taken out, they have to be sanitary, but they don't have to comply with 3A Standard 78. Within that standard, it states that if there's an internal angle on the spray device, it has to be at least 1/8 of an inch if it's less than 135 degrees, unless it's a bearing surface. And then again, the reason for that is because these bearing surfaces have to fit closely together for spinning spray devices so that they fit close together, which helps it to function. Meat and poultry, they don't care. They say it can be less than 1/32 if it's cleanable and inspectable. That's it for me. Thank you.
Thank you for having me here, and I'm Cari Rasmussen with Commercial Food Sanitation. And in my time with CFS, as we call ourselves, I've spent a lot of time working and supporting the produce industry. And a lot of this will be centered around the leafy green industry in particular. But I'm just excited to talk a little bit more about this because before lunch and yesterday as well, we've heard a lot about the dairy industry, a lot about the meat industry as well, and how foundational those industries have been when it comes to hygienic design. And there's a lot to be learned and to be applied in the produce industry. And so I'm here to help tell that story, and I'm honored to be here to help tell that story. So our story is going to have 3 chapters. We'll start with a little bit of history. We'll talk about a very brief history. Don't worry, I know you're all ready to go to sleep already, wishing you had that milk and cookies in hand, but we'll go very briefly through the history. We'll also talk about the reality of produce, both as a product itself as well as the reality of where produce is in design today. And then we'll end on that positive note, which is the exciting possibilities and what's to come, what's happening now, as well as the future state of the produce industry. So let's go through the history, chapter 1. So we're going to start with the evolution of hygienic design. It's okay, I only have about an hour and a half or so of this that we're going to go through. But in reality, you can see the timeline is very short. In short, in the way of, I'm only going to key in on a few things. This isn't extensive, but there was just a few points that I wanted to point out. And starting back in the 1920s, this is where hygienic design standards are first introduced, based on my research. And really, that's what 3A was and how 3A was really a part of that at that point in time. And then as we go to 1956, this is where 3A symbol is introduced commercially, which is great. So as 3A progresses, as we have that ability to use that symbol, put it on equipment, et cetera, it becomes something that is a beacon of hope for processors who are looking for a way to identify if their equipment's going to be sanitary or not. We're going to skip to 1989, and this is where EHEG, and we've heard quite a bit about EHEG, that is founded. So, similar nature as we think over the pond, so to speak, over in Europe, thinking about standards and hygienic standards. And then in 2002, the Sanitary Design Principles, the 10 principles that the American Meat Institute at the time have come up with. General principles, very foundational, very, very easy to use. We've seen some snapshots of those as well. And ultimately, that brings us to today. And where are we today? We're in continuous improvement. So over the last 100 years, we've made a lot of discoveries in hygienic design. We've had some trials and errors, and ultimately, we continue to learn. And as we continue to learn, we're making improvements to the existing standards, to the existing principles. AMI, now NAMI, the North American Meat Institute, they've just launched their 2021 standards with improvements. So it's exciting to see. We've talked a little bit about GFSI as well, so they're introducing hygienic standards as well as a part of their scheme. And it's really looking at and emphasizing hygienic design. So let's go into the evolution of produce and taking a look at their timeline. Now, what might strike you is their timeline doesn't start back in the 1920s. I'm starting in 1998. So we're talking about 25 years ago. So where were we in produce? Good agricultural practices and good manufacturing practices were developed specific to fruit and vegetables. So we're talking just 25 years ago, we're really starting to take a closer look at GMPs and gaps. Then as we move forward to 2004, in the last day and a half, we've seen a lot about recalls. We're going to see more about recalls as it relates to the produce industry. Here we have an outbreak of salmonella that's linked to Roma tomatoes. And prior to this, there wasn't a lot in the news. There wasn't a lot of fresh produce that was related to outbreaks. So really, it's been just A short, roughly 20 years ago, is when we really start to see outbreaks associated with fresh produce. As we go to 2006, some of you may recall this recall with E. coli 0157H7 in spinach, which led to several deaths as well as an investigation. And at this point in time, with traceability, it was very hard to determine the root cause of what was causing the illnesses. Where was the the E. coli in this case coming from? And so you have to pull everything from the market. The FDA says we have to pull everything from the market. We need to shut down the spinach industry because we don't know where this is coming from. So this recall was very much felt by the industry, a lot of fear in consumers to eat spinach at the time. As we move forward to 2011, we heard about this actually just this morning, if you were here for this session, about the Listeria monocytogenes outbreak in cantaloupe. And that one, again, just to recap, what was interesting here is it was related to equipment. Part of that root cause was related to equipment. Is it designed for its purpose? And the answer was no. That equipment was used to process produce and vegetables and things that were not intended to be eaten in the raw state. So you have raw and ready to eat at play here, as well as you have wash water that wasn't being treated properly. That's an issue, that's a challenge. And also in the environment, we have standing and pooling water. So we start to take a look at that importance of design, the importance of really understanding your product. So there's a lot to be learned. 2011, as we know, FSMA. The FSMA was enacted at that point in time. Produce safety rule is introduced. So this is where, if we look back in 1998, there was guidance that was developed, but it was not a part of any regulation. So now we have a produce safety rule that is put in place that really uses what was in the gaps in the GMPs, using that as a foundation for what's in place today. And just a couple more I'm going to mention here briefly. 2015, Listeria monocytogenes in caramel apples. At this point, roughly 8 years ago, apples were not thought to be at risk, really, of pathogen contamination. The exterior, the skin seems to be, fairly robust. However, think about the product. I now am going to insert a stick. It's going to break through the outside skin and go into the interior flesh. I'm also now going to cover it with caramel. So I've just created a nice barrier between the skin and that caramel. So we really cannot be complacent. And that's where the industry is at, is we can't be complacent. We have to think about these changes. Even these small changes, what seems small, could make an impact. And then the last one here, 2018, 2019, romaine lettuce. We seem to see romaine lettuce now in recall news, unfortunately. And ultimately, with this and a lot of these recalls, we're going back to harvesting, and we're going to talk more about that, and just some of the challenges in the supply chain when it comes to our leafy greens. I wanted to go through the history, and we're going to move on here to Chapter 2. But this really sets the stage for Chapter 2, which is the reality of produce. And as we've mentioned, we have about a 20-year history, so to speak, in produce. So what changed? What's happened in the last 20 years? In my opinion, it could be several things, but one thing is our ability to detect and identify those root causes. Absolutely, technology's allowed us to detect. And also potentially the way that consumers are using the product, the convenience factor. Now we're mass producing our bagged lettuce, our clamshells, et cetera. We're further processing in a way that perhaps we weren't, prior to 20 years ago. But all to be said, we need to understand the reality of produce. In the last 20 years, it's been a wake-up call for the industry. So let's start with the story of produce, and really the beginning is how it's manufactured. So when we talk about processing steps, I always think about what I do. How many of you go to the store and you actually will buy a head of lettuce or the 3-pack of romaine? So what do you do with it? You take it home, you dice it up, you rinse it off, you put it in your spinner, and then you dry it. Put it in the refrigerator, and it's good. I find it's good for actually maybe a little bit longer than when I get it already prepared. But with that, when you take a look at that salad spinner, that's what it looks like in the plant. Just think bigger, and also think stainless steel. But with that, when I talk about the process, there's no kill step when it comes to produce. We're bringing in produce from the outside, we're bringing it in, and we are going to dice it, slice it, spin it, wash it, spin it, and package it. There might be some water treatment there, but that water treatment is just to help with the water. We're getting maybe 1.5 log reduction of pathogens, not a 6 log reduction. So that's the reality of produce. Another reality of produce is location. Where is produce grown? It's outside, right? Most of it, at least, is outside. And not only is it grown outside, but who are your neighbors? That's really important, and that's where a lot of these investigations have looked at. Who are the neighbors at these large fields? It could be large cattle operations. Do we have the potential for cross-contamination related to the irrigation water? And that's really where a lot of those root causes of those recalls that we showed earlier, it was really going back to the growing area. And that's where the location is really critical. And the industry is really looking closely at what they can do and working together to address the challenges of the location and the reality of where produce is grown. Another reality is that produce is actually on the move. I don't know how many of you realize this, and you've probably seen it a little bit in the news, but we talk about Yuma, Arizona quite a bit for growing fresh leafy greens, as well as Salinas, California. And the reality is that you can only grow in Yuma, and you grow in Yuma because it's great between the months of about November to April. And then you need to move to Salinas because it gets a little bit too hot in Yuma, and so you need to move up to Salinas. And so a lot of processors are actually physically moving. Some of them move physically equipment from Yuma up to Salinas and then back down. So you look at this movement twice a year, and that's really that's the reality of produce, is that you're moving your location based on where you can grow at that time of year. Related, these other items are related. The clock is ticking. And what I mean by that is in some cases, when we think about other produce, if we think about berries and tomatoes, some of these harvest seasons are very finite. These plants will get up and running, and they'll run intensely for 3 to 4 months, and then they go idle for the rest of the year, waiting for that next harvest season to come around. And so the reality is that they have to get up and running, completely open up a plant, and then kind of decommission it, if you will, and wait for the next harvest season. So I'm not sure how many of you have to deal with that in your facilities, but if you think about having to come up, and get running, run all out for 24/7, and then you have an extended period of idle time, that can create some challenges, absolutely. And that's related to this last point, which is that the produce industry by nature has seasonal employees. So if you're moving location, if you have a finite harvest period, you have seasonal employees. Employees are coming in, they need to be trained. Whether they were here last year or not, they need to be trained, they need to be retrained. And the reality is that can be challenging as we think about having to get up and running every season. And so we'll shift gears now that we understand the product a little bit better. Let's shift gears and talk about produce design reality. And really, the story of produce processing is a story of legacy. So as I mentioned, 20 years. How long have you all had pieces of equipment and infrastructure? 20 years? Probably, and probably a lot longer. So when we think about the reality of what the produce industry has learned in 20 years, we also have the reality that they haven't been able to completely redesign their facilities, move into new buildings, get brand new equipment. And so that's where the design reality is that we have legacy equipment. And none of this is really new to and unique to produce, but this is a reality that it's been a short period of time that they've really understood the risk, and they've had to really work on identifying that risk and then how to combat it. So let's talk a little bit about legacy equipment. And we've talked a lot about equipment in the last day and a half, but really in the produce industry, as with a lot of industries, the equipment is not always easy to clean. It's not easy to access. Sometimes you can take a look at your equipment floor or your production floor, and it might look a lot like this beach, oddly enough. I see a lot of umbrellas. They look nice and shiny on the outside. It looks great. But what's going on underneath that umbrella? What's that support structure look like? I don't know. I can't see it. I can't access it. How do I get around this equipment? As we know in most, I would say across industries, we are putting more equipment and more lines right next to each other. We're going, horizontal, vertical, any way we can to make, more volume and meet the need. And so the reality of equipment is that the equipment that's legacy from 20 years ago wasn't designed to be easily accessible, maybe not understanding the potential risks. And as we know, when we start to see recalls, we start to need to, maybe we're looking at our cleaning. We're cleaning every night in fresh produce. We're definitely using chemicals every night. And so that can actually, cause some of that wear and tear. And just, we're only gonna really get to what we can see. The next reality in design is the story of infrastructure. So our infrastructure, we've touched base on this a little bit today and yesterday as well, but as we could imagine when it comes to infrastructure, same thing, legacy plants. We have wash water systems. We're cleaning every night. Do you think there's rusting in some of the overheads? HVAC units that are struggling to keep up with the airflow, condensate that's being formed. This is the reality of what we see in produce processing, is that that infrastructure is not necessarily being able to withstand the exposure that it has to the chemicals that are being used. As well as we mentioned before, more product, more volume, more equipment, more traffic, the floors get beat up, we have cracks, we have crevices, and this is really, again, the reality that we're seeing in the infrastructure. And then we have the story of the legacy layout. We think about the layout of a facility. If you don't think that you have too many risks, you're bringing in the product, you wash it off, you're gonna put it in a bag and send it on its way, well, I don't need to have a lot of different areas of my plant. An open kitchen concept sounds great. We all love open kitchen concepts in our houses. We love to invite our guests in, but in produce, there are guests that we don't want to let in. And so if we are thinking about our hygienic zoning, if we put our hygienic zones in place and plan for it, that's fantastic, but that's not where we're at with our legacy layout. So now we're trying to kind of retrofit. We're trying to put in chains, trying to put in some barriers, trying to create a vestibule and go over here to get your smock for this hygienic zone and then walk through here to wash your hands and sanitize your boots. And it can feel like you're jumping through hoops just to get to where you need to go. As a supervisor, I could imagine some of these facilities, I'm changing my PPE completely 3 times just to see, 3 and sometimes 4 times just to get from point A to point B, from receiving all the way through. So you can imagine some of the challenges, the change in habits that we expect our people to go through, the behaviors that we expect. It's different than it was, and we're dealing with that in our legacy infrastructure. So you're probably thinking, what hope is there? I've gone through 2 chapters of this book, and you're now really wishing you were sitting on the carpet eating milk and cookies and feeling really, really much better with some comfort food. Well, don't give up. I did promise that there's a 3rd chapter to the story that I'm going to tell, and it is the exciting possibilities that we have, because the industry really is taking a step up. The produce processors are taking a look, using data to drive decisions. And that's when I want to spend some time here as we talk about the exciting possibilities in this last chapter. So headline news, equipment design is progressing. And when we take a look at this, there's several ways that it progresses. We have PEC, we call this periodic equipment cleaning. So as we mentioned before, some of our legacy equipment, we can't clean it on a routine basis. So we need to clean it on some frequency. And quite honestly, in my experience, when I had started looking at produce facilities 7 years ago, if I went into a produce processing facility and said, hey, on your master sanitation program, can I see your PEC items? Like, what are you cleaning? What are you tearing down? That wasn't even a part of their story. They're like, what was that? We need to tear down equipment on some frequency? Yeah, you do. Can you see everything? Are you undoing all the bolts on this piece of machine? Can you see into this, see what's going on between these nooks and crannies? No? Okay, then we need to take it apart. And so the reality is, and why this is exciting, is that when we go into processing facilities today, PEC is very much more common to see on a master sanitation schedule. Oh yeah, we absolutely are taking off this belt on X frequency so I can get into those wear strips, so I can get into that structure of that conveyor. I know that on my spin dryer, I need to take off these parts and pieces so that I can get into it. I absolutely, have to do this program, and I have it built in. I have my maintenance team assembled, they're ready to assist, and my sanitation team knows what to expect. And that's what's exciting, is that legacy equipment, we're addressing it. We also have original equipment manufacturers involved. This is what we've seen in the industry as well. We've helped facilitate some of these conversations with the industry, bringing together OEMs and processors, talking about the equipment, the hardest to clean pieces of equipment. What can we do better? How can we help and enable the success of each other? And the design changes are fantastic and exciting to see. And also what we're seeing from some OEMs is also stepping up and really helping when it comes to sanitation guidance. Hey, here's what we would suggest that you do on a routine basis, and here's how you do it. Here's what we would suggest you would do on a periodic basis to clean. And it's really stepping up, and the OEMs are stepping up to work with the industry, understanding the challenges that they really have. And that's what's really exciting, is to see that collaboration that we see taking place in the industry. And legacy changes are happening. Another headline news item. And what I mean by this is that legacy equipment that we talked about, again, we're not getting all new equipment in, unless maybe you get the chance to build that new line, which is also happening, but we still have legacy equipment. And with that, the processors are really looking at, what can I do to modify? Can I make this a little bit better? And no change is too small. I've been in produce processing facilities that there's a hook that you have to hook onto the dryer basket. You lift it up to put it in the spin dryer. They're looking at the design of that hook. And they understand the importance of the design of that hook because it's right over the open basket. And they're saying, I need to clean X number of hooks every night. How can I make this easier? And I've seen redesigns, and I see the pride in the produce processors when I talk with them about that. Hey, show me what you've done. What are you looking at? We've redesigned these hooks, and this is what we've been able to do. We've reduced the number of niches that we've had to worry about on a daily basis. They're also taking a look at, again, when we take a look at moving dryer baskets and or trash bins, they're lifting those up off of the floor. Whereas you used to have very minimal clearance, those dryer baskets, it's just like that spin dryer. You've got holes. It's all product contact when we think about a product contact surface. When you're 4 inches off the floor, any risk of cross-contamination? Yeah, probably. Harder to clean and see underneath that dolly? Yeah, really difficult. And these processes are taking a look, how do we lift this up? So now we're getting to those 18 inches off the floor. They're redesigning, they're fabricating new ways to get things up and off the floor. So that's really exciting to see. And we see the supply chain involved. And with this is going all the way back to the beginning, looking at the field. And some of you, if you've paid attention to recalls in recent years, we've seen the harvesting equipment being called into question and potential root causes. And the industry is working together with the harvesters to really understand that equipment and what can we do better. We need to take a look at this equipment. It's used outside. There are sanitation protocols, but let's take a closer look at those protocols and how do we enable success when it comes to sanitation in the difficult conditions that we're asking you to work in and also clean in. What can we do differently when it comes to the design of the equipment that's out there harvesting our fresh produce? So it's exciting to see this change where, again, the industry is really collaborating together to look closely at design. And the story is just getting better. We just started chapter 3, so we can't put the book down yet. It's exciting. Infrastructure updates are absolutely occurring, and I have a lot of passion around this. We talked a little bit earlier, and I like the analogy of, like, if you have the best equipment and you put it into a house that's run down, have we really made the gains that we expected to make? Probably not. So we need to really address our infrastructure. And the exciting thing is that what I've seen in the industry is that they are working on remediating legacy infrastructure. So removing the rust, getting it back to bright, taking a closer look at those overheads. And with that, it comes with capital improvements. And they're spending money. And spending money on infrastructure, you don't always get that. It doesn't seem like a quick ROI, right? It's just something you have to do, so it can be hard to get that money. But I was just at a produce processor recently, and they've spent over the last couple of years over $2 million to fix the roof, and also on the inside, working on the ceiling, to clean it up, to get something that's going to be easier to maintain and easier to keep clean. Because they know this is the long game. They know that if they're going to stay in business, they absolutely have to manufacture under sanitary conditions. And infrastructure is a big piece of that. So you need to spend some money. You need to spend some time there. And then, exciting possibilities are in the layouts. And we see that layouts are improving. And a lot of that is just redefining your hygienic zones. So instead of thinking that, we have almost, one big zone and you bring in your raw material and then you have it packed out, really breaking that down and thinking about the risks, understanding that when I start to slice and dice this produce, I need to think about this as a zone. I need to minimize the external pressure. I already know I have pressure coming in from my raw material. I don't want to add to that. So they're really thinking about those zones and those hygienic zones, redefining those. And once you've redefined them, implementing those controls. So looking at your GMPs, taking a look at your color coding systems. How do I make sure that I'm in the right zone and doing the right thing as I'm moving throughout my facility? So it's exciting to see the industry taking those steps to get to where they need to be when it comes to the layout. And there's a lot of exciting possibilities because really we're expanding the picture, and the produce industry is expanding the picture. And with that, we have new products. There's convenience products that are being added. So usually with a produce facility, you're under FDA, but now they're producing salad bowls that have a protein added, or parfaits that have yogurt with mixed berries in it. And so now they're looking at that USDA space. And with this is all an opportunity to design for greatness. And that's what's exciting is they're taking the learning, they're learning from other industries. And they're absolutely, when they're building and rebuilding, they're designing for greatness. They're taking a look at the layouts, they're trying to get it right the first time. And that's where they're considering also design from the field through processing. We just talked about that. So we're taking a look at, from the field, it's important that we have controls, and we need to continue to take a look at our agricultural practices as well as the design of our equipment in the fields. And they're really looking holistically through the supply chain because they know it's critical that when it gets to the consumer, that it truly is ready to eat, because the consumers are depending on us to make food that's ready to eat and they feel very safe and comfortable about consuming. And ultimately, there's maximizing, and this is really linked to the first one, we're maximizing design. When we have expansion opportunities, when we have new builds, it's really looking at it using the history that they've learned and applying that history, and that's really critical. And one of the last slides we'll be talking about, just a couple here left, but how do we achieve design success? And this is where the industry's been really taking this head on, and it's really working together. Thinking cross-functionally, working with the OEMs, working with other, outside external parties, but also working internally. So thinking, if we need to be pulling in the same direction, and so we need to work together, having quality, sanitation, maintenance, production, people safety. That's how we design for greatness. We work together. That's how we're going to get to success. It's using the resources. We've talked a lot about resources, using checklists, using standards. And so the industry, although it might not be targeted to the produce industry, they're looking at things such as, hey, 3A could be the way to go because we know that there are standards in place. Does it have that stamp? Is it EHEG approved? We have standards. We can utilize checklists because we can, as we look through the checklist, we can understand the risks and how to mitigate those risks. So let's use those checklists, and we see a lot of interest in utilizing these resources that are available that, again, the dairy and meat industry have been foundational in creating. And it's training. We've talked about this quite a bit, too, in the last day and a half, but we need to enable the success of employees. It's not enough to do your best. You have to know what to do, and then do your best. It's one of my favorite quotes when I do training is you have to know what to do, and it's knowing the background, it's knowing the why it's so important, and that's what we see in training. The future of produce, hopefully you've left it, it's exciting. We've seen a lot of change, a lot of updates in a fairly short history when you look at 20 years. And what we've seen is it's going to continue to grow, and there's going to continue to be changes. The growing practices are changing. Controlled environment agriculture, CEA, is very much taking root here, at least in the United States. So think about greenhouses, think about indoor growing. We're seeing a lot of facilities that are doing this now. And ultimately, with any of these changes, as we continue to expand, make more value-add products in the industry, we need to keep design top of mind, and that includes our indoor growing. So it's interesting because we've seen a lot of folks coming to us for some training in this space because I think they need to know a little bit more about design, a little bit more about sanitation, because even though you're indoors, you may have taken out one of those potential factors of cross-contamination, but you haven't eliminated them all. So it's really important that they learn from the industries, learn ideally up front so that they can help be preventive in the future. So with that, I'm not going to put the end at the end of the story, although I have come to the end of my story for today. I think what's exciting is that there's not an end really to the story of where produce is and where they're going to be, because they're going to continue to improve. We see that in the brief history. And so I'm excited to have been able to share just a little piece of that with you today. Thank you. Really appreciate it.